Can you hear me okay? Okay. Good morning, everyone. Happy YAPC to you. Everybody having a good conference? Woo! I'm Jason Crome. I'm here to talk to you about logging and analytics with Perl and fluentd. So who's this talk for? Like to think that I have a little something for everybody today. So if you want to know a little more about enterprise logging, then I got some stuff here for you today. If you want to know more about structured logging and what it is, I'll tell you a bit about that and give you some examples. If you want to know more about fluentd, you'll see a little bit of what it is and what we're doing with it. So I have some code, some setup, and a lot of discussion about what it is that we're doing. So who am I? I'm a project manager at All Around the World. I work for Curtis Poe, and I'm the project manager for Veer. Has anybody here heard of Veer? Other than the two other people in the room that have worked on it. Veer is a massively multiplayer online game that's written in Perl. And if you want to know more about the game, I'll be happy to tell you all about it after the talk, because I don't want to eat too much into this time. I did some other things with Perl prior to working with Curtis. I'm a Dancer Core team member. And something I want you to know, I'm new to this too, actually. I'm not an expert in enterprise logging, but I've been kind of figuring this out as I go along. And as our needs have adapted, I've had to learn a little more. So, to give you an overview of what the game is built with, we use Catalyst, Template Toolkit, deevak, Moose, and Postgres. And at all levels of this, we need to get information out. And this is one of the reasons we took Fluent, is because it is going to allow us to do that. So a little reminder of what logging is, the process of recording application actions in state to a secondary interface. For us, it's really, really important to log the actions that our players are taking, and it's equally as important for us to log the response that the game produces when the characters interact with it. And this is all getting recorded through Fluent and eventually to a Postgres database. The reasons why we log are really, really important. The most important of these is to prevent cheating. Anybody who's played a massively multiplayer online game realizes that cheating is pretty prevalent, whether the game is very popular, whether it's not popular at all, or even mildly popular. Players like to get ahead, and they like to get ahead by whatever means they can find. The more information we have about what players are doing, we can figure out the ways in which they are cheating. We can fix those ways and react appropriately. Also important to us is we need help determining the effectiveness of our game content. As developers on the technical end, we've got a lot of different ways to measure the effectiveness of what it is that we're doing, but our creative team is not quite so lucky. And they spend a lot of time making these really elaborate missions and activities for players to do, but they don't have a whole lot of tools at their disposal for getting feedback on them. So they might have this really elaborate mission, and nobody is taking this one really cool path through the mission graph, and they don't understand why. The more information that we can give them from the game, the better off they are to make changes to that mission and create a more engaging experience for our players. Veer is free to play, but we plan to make a lot of money with it. And in order to do that, we have to know what it is that players are spending money on and the circumstances under which they're spending money on these things. And it's just as important to know what we have for sale that they're not spending money on, so we can figure out why that's the case. Do we need to make adjustments to the things that we have for sale? Do we have to make some change to the game to make this item more worthwhile? The more information we get out of the game, the more that we can do this. And one thing I'll talk a bit about later is by logging information for things that happen in the game, it's going to allow us to dynamically change the difficulty of the game later on. So why fluentd? To give you a little overview, fluentd is a log collector or aggregator. They call themselves a unified logging layer. And the important thing for us is that it supports structured logging. What many of you are familiar with logging is you call a method and you write an entry out to a log file, or maybe it's just a row in a table in a database. Structured logging is different because you have to, in our case, we have to record the state of what's happening at the time an event happens. And what the state of something is at that point may differ based upon what that thing is. Am I logging an action that a character did? Am I logging the outcome of a fight? So having something that supports a rich data structure is really important to us. And we can't easily model that with a flat line of text. And while we can boil everything down to a flat line of text, it's not really going to be easily parsable, and it's going to be a lot more work than it's worth. fluentd allows us to log from any layer in our stack. We can log from the front end, we can log from deevak, Catalyst. It doesn't matter, it's all pretty much the same for us. It's asynchronous, which is nice. We can fire off a log message and we can forget about it. It's clusterable, it's expandable. And very important for us right now, because we're not making any money on the game, it's self-hosted. We don't have to pay anybody to run fluentd. We can just throw it on one of our development servers. It's memory friendly, it's got built-in reliability, and it's super, super easy to set up. It's very expandable because it's written in Ruby, and if you don't like Ruby, you might not like fluentd. However, the guts of fluentd are written in C, so it is actually very, very fast and very, very lightweight. If you need to expand it, you can do so with Ruby. It also has a very rich set of inputs and outputs out of the box, so chances are whatever you're trying to put into it, whatever you're trying to get out of, Fluent probably already has it. Another reason not to use fluentd, for most projects, honestly, it is probably overkill. Definitely for any pet or small projects that you're doing, but if you have some really serious and really complex logging needs, I would highly recommend taking a look at it. I'd be a little remiss in not mentioning some of the alternatives. Most of you are probably familiar with these in one way, shape, or form. Logstash, Splunk, Loggly, and Papertrail. Loggly and Papertrail both being hosted services. Not really going to talk a lot about them, but just so you know, some of the other products, this is in the same category as. The way that we funnel information into fluentd is through logforpearl. And the reason why we use it, well, frankly, it does what we need. It has everything in the kitchen sink, so anything that we'd want to do with it down the road, it already does. It easily integrates with Catalyst, and there's already an appender for fluentd. We were all prepared to write one, and then we actually just kind of stumbled accidentally, I think, across the fluentd appender for logforpearl. So, and we'd already had a bunch of logging code that had been built up around logforpearl anyway, and not having to go back and change that was actually a huge plus for us. The things that we directly log from now, deevak, a lot of other Moose-based classes. We have a role that we can insert in any Moose class that allows us to log from it. Catalyst, it already has logforpearl plugged into it. We can, but I don't believe that we do right now, can even invoke the log from a template toolkit template. And then eventually, from other levels of our stack, as our infrastructure grows, we'll be able to send messages from syslog and other system services directly through fluentd to one of its appenders. Things that we're going to do on the back end, and I'll talk about some of these a little bit later, is being able to wire certain types of events from our servers to set off alerts in NIGOS. And as our logs grow and as we have to find information, we're going to want to tie products like Elasticsearch to help us farm information out of this again. So what do we log in the game? We log all the things. More specifically, we log everything, seriously, and that is the goal of this. With a massively multiplayer online game of any sort, you've got to log all sorts of things that you might not otherwise care about, because you never know when they are going to be important. The other reason why this is important is nobody on this team are veteran game designers at all. In fact, some of the people on this team, not naming any names, were not really any game players either. So we're all kind of figuring this out as we go along. And the more information that we have at our disposal, the better decisions that we can make, the more balanced and the more engaging game that we can make for our players. This is a really small list of all the things that we care about in the game. And it's all over the place. It goes from a character login, errors and warnings, which should be pretty obvious, different events that happen with characters, actions, randomness, which I'll come back to, any courses they take, URL spoofing attempts, chat hacking, which has been known to happen in games, transfers of items, auction house transactions, and then eventually what we want to tie to this is as the game grows, we have a lot of A/B testing that we need to do, and we even want to filter the results of the A/B testing through fluentd. So I mentioned logging randomness, which may seem a little odd to all of you, but please hear me out on this one. Anything that is left up to chance in a game like this, and there's a lot of things that are left up to chance, we need to log these things to figure out the effectiveness, either through the methods which we are coming up with these random determinations, through the module even that we're using to produce the random numbers. So having all of this encapsulated and easily loggable gives us a really good tool with which to measure the effectiveness of random events in the game. So we created a role for this, viewer role random. And anytime that a random number needs to be produced, either in combat or through a skill check or a stat check, this role can be included, and any of the methods that are provided by the role can be used, and each one of those methods are logged. As of right now, we're still just collecting information. We're still heavily in development and hoping to test by October. So the only information that we have is what we've produced in development. And this is going to get really interesting as soon as we actually have real players in the game, so we can see what it is players are actually doing. By having this encapsulated and easily loggable and measurable, it allows us to easily modify the difficulty of all the roles later. Methods that we're going to do that I'll explain in a little bit. But it lets us change the manner in which we generate roles. The way that we've always done this so far is if we need a skill check, there's just like one check, you give it a probability, a range of things to roll through, and it gives you a number back, and do you succeed or fail? Our creative team lately has been saying, well, an all or nothing approach is probably not going to be sufficient for the types of things that we have going forward. Maybe we want to let the player have 5 roles, as it were, and we need 3 of those to succeed. We couldn't do this if we didn't encapsulate that logic, and if we go ahead and make this change, we need to see, was this the right change to make? Again, we have it encapsulated, we can easily log it, and it allows us to do that. We have our own set of classes, which I'll explain, for producing the log entries. And once this is done, everything gets shoved into logforpearl at that point. Logforpearl then sends it through fluentd, and then it gets written out to one of the fluentd appenders that we use. All the log methods that are provided by Catalyst automatically get sent through fluentd as well, so that will get written to any of the outputs that we have configured. And the logs are structured data. Our logging classes produce a Perl data structure. That gets converted to JSON if it gets sent on to fluentd. If it's a local developer working and they don't happen to have a local install of fluentd, it's going to get stringified. I'll show you how that happens too. All of this happens because of log message structured. It was a really good starting point for us for producing structured log messages, but it wasn't perfect. It had some problems. When you pass log message structured a data structure, it automatically logs all the attributes. That's a problem because some of the things that we need to log are pretty massive in size, but we really only needed a couple of things for the type of, we only needed a couple of attributes for the types of things that we were logging. And the other part of the problem is log message structure does not let attributes contain objects. Any of you who know Curtis and the way that he likes to design software, everything is very nicely organized into objects. So the easiest way for us to log is to send an object to the logger. And if we were automatically logging all those attributes, it would be a problem. A great example is a lot of things that we're logging need certain information about the character. It needs to know the character's current stats at the time that it happened. If it's combat, it needs to know, what the player's health is at the time that this event happened. But we only need a couple of things. We got a lot of character data, including the weapons that they're using right now, the ships that they own. There's a lot of things there, and we don't want all of that. We just want very, very few pieces at any one particular point in time. So our solution was coming up with vir role log event. And this, in combination with a special trait that we use, allows us to pass in an object and some other information and ignore everything that we don't want. And what's really nice about this solution too is at the attribute level, we've made it so that things will only log at a given level of verbosity. So we care about how detailed our logs are in certain cases, and so we have different verbosity levels, everything from off to a little to a lot. And the other nice thing that vir log role event has provided us is that we can change what we care about with logging without actually changing any of the logging calls in the in the game. So if we're logging randomness, better example, we're logging an attack in combat, and for a while we only care about what the player's current stats are and how much damage they do at that one point in time. If later we decide that we also need to get more information about the weapons that the player is using at the time that this log entry is done, we don't have to change any of the individual calls to log event in our code base. We can actually go back to the definition of the log event and tell it that we want more information going forward. So we can actually add or remove information without changing any of the implementation anywhere, which is a huge win for us. Apologies if this is a little hard to read, but I chopped out some of the relevant bits of one of our particular log event roles. And this shows that we're passing it, that this log event expects a character object, but we are only caring about one particular trait of that character object, in this case an identifier known as a slug. And we know this is the one that we care about because we've given it this special trait that we've created called logged. So I talked about randomness a couple of times now, so I want to show you one of the implementations of this. In vir role random, we have this attempt to method, and it looks pretty straightforward. We generate a random number, and we compare that random number to the chance we have at success, and we determine, does it succeed, does it fail? And if so, it invokes our log event method with the type of event it is and some other information, and then it returns to whoever called it. And the implementation for this, again, I apologize, it's hard to read, but it's pretty straightforward. It's just a moose class. We include the log event role and the logged trait that we used, and just like defining any other moose class, we define the things that we care about. And that's it. That's what adding a new logging event is in our system. It's really, really straightforward. If you can write a basic Moose class, you can add a type of logging event to our logging system. I'll give you a more complicated example. In Veer, we have everything runs through an exchange. And that's and an exchange is just exchanging one type of resource for another. That resource might be in-game money for an item or a weapon. It could be an amount of in-game money for a university course to get a player a new skill. It might be exchanging one item between players. But all of this gets funneled through oneexchange method. And this is just one example that we have in the game where a character purchases a visa to travel to another nation station. And again, it's getting a little harder to see, but it's just another Moose class. This one a little more complicated. And we include a couple of different things. We include our log event role. But we have some other roles there that you see, character location, and character vitals. We have a lot of canned roles that we've created that automatically know to even pick apart a character object to say that we care about only these specific things about the character. So instead of making our class definition more complex, we can just include one of these roles, and it even does some of that hard work for us. And the rest of it is really not all that complicated. It's, again, just a really straightforward Moose class that defines what we care about in this log entry and how we want it to behave. One final thing. I've already thrown a couple of examples at you. This one's a little bit different because if you remember a few minutes ago, I mentioned logging verbosity. This is something that we have at the end of our root controller in Catalyst for access logging. And this is important to us because we want to get an estimate or a pretty good idea of the time that it is taking the game to finish a request start to finish. And so at the very end of our root controller, we have this log event method, and it captures some information. If you look at the definition of this log event, though, you'll see this one is a little more special, the UA, than other classes that we've defined. It's got a log level of 2 there, which means that in our game configuration, this particular piece of information is only going to show up in the logs if we have the verbosity cranked up to 2 in this particular case. And in Catalyst, in our Catalyst configuration file, we've got a listing of all the possible logging events that are available to us and what we want the level of verbosity to be. In our veer.conf file, which everybody gets, every server, every developer, we have what all the defaults are, and each developer then, for whatever it is that they're developing, testing, or even on our development production servers, we have the ability then to override that in our local configuration file. So if we temporarily need to get more information about one thing, all we have to do is increase the verbosity level. With regards to verbosity, there's 2 things that we care about, one of which we've implemented, one of which we haven't had to yet. That's overall verbosity versus individual verbosity. Overall is what we care about now. It's what is the game in whole doing? How much information is it logging? How much information are we getting out of combat? How much are we getting out of the auction house? Individual logging is a future feature that we have planned, and it's one of those things that we're going to need to turn on in certain select instances, mostly when we're concerned that somebody is cheating or when somebody is accused of harassing another player. If there's something that we might have to step in and take information on, then we actually have to have a smoking gun so that we don't act upon hearsay information. And like I mentioned, controlling the level of verbosity is pretty easy. This is an excerpt from our vir.conf file in Catalyst, and it's just really simple to see. Axis log is what we care the most about, so we've got the highest level of verbosity on that. We have the lowest level of verbosity on Exchange. If you look down a little bit, we log scavenging attempts in the ruins. We don't really care how that turns out. So it's really pretty flexible and really easy for us to control the level of information that we're getting out of the game on a subsystem by subsystem basis. So I've run it into the ground about how we log and what we're logging. So where does all this information go? Well, if you're a developer, you probably don't want to have to worry about setting up Fluent on your system. And so we actually just write it to the local file system like most other logging that you're accustomed to doing. For our development and eventually production servers, it's going to get routed through fluentd to Postgres. If a developer wants to set up fluentd, they're welcome to do so. And all they have to do is change their logforpearl appenders to say go to Fluent, not the local file system. And if you want to do both, Fluent's nice. It lets you set up multiple outputs. The developers, if they even wanted to, could log their information to our development environment's fluentd instance. We don't, but we could. Ultimately, it's JSON that gets sent to fluentd. That gets represented beforehand by a Perl hash. Any of you who've tried to stringify a Perl hash know that you get keys back in hashed order, which is a real pain in the ass if you're a developer trying to track down what's happening in a text file. So we did a little magic with log message structured, and we used hiix hash to help us order the hashes. And then we can stringify them and write them to disk at that point, or we can use log message structured stringify as JSON, which is what happens when a message gets sent to Fluent. And it's not a crazy amount of code. Again, it's just more moose. And all the magic happens in this isHash function. And not a whole lot of craziness to see there. A point of discussion in all of this was, so we send this information through Fluent, what do we do with it on the back end? Well, we always knew that we were going to deal with Postgres because Postgres is the one database everybody should be using. But the question was how we were going to store it in Postgres. I like flat specific tables that that we would log to very specific individual things for analysis. A couple of the developers here in the room for me made a great case for the JSON data type in Postgres and all the cool things that we could do with it, and that we could index the data inside of there, and we could do just as meaningful, if not better, queries out of the JSON data type. And eventually they won me over, and that is how we're storing everything in Postgres, is JSON. And it's really nice too, because other services that we're looking at using are going to use this exact same data format as well. This first slide just shows how easy it is to set up that table in Postgres for fluentd purposes. You specify your config information, what table you want to log to, and you mention it, what the timestamp column is, what the tag column is, and then what column the information gets dumped to. And in this case, it just makes a really simple table in Postgres. If you're a developer that's chosen not to use fluentd and you're just logging to your local file system, this is just a sample of what some of the text output looks like. It looks like most other text log entries after it's been stringified. And as you can see by the bottom example, the same process can actually produce JSON and just sends it straight to fluentd. testing all this, again, any of you who know Curtis knows that everything that you do must be tested. It must be tested well. This is a problem with log4pearl sometimes. Any of you who've worked with test log4pearl may be aware of some of its shortcomings. Logs must be easily testable, but they have to be turned on to be tested. So we ended up having to do test roll log testing to help us out with what we needed to do. And what this allows us to do is look for specific hash values in a log message. So we can specify in a test that we want something to happen and we're expecting to get this log message out in the tail end. And what this roll allows us to do is then we take that action and then we check the logs to see if that's what actually happened. And the way that test log4pearl works is that you can only check for two things. You can either check for a regex or a string. And that's a huge pain in the butt. We thought about testing individual log events rather than sending them through log4pearl. We could have done that. It probably would have been easier. But we don't think it would have been the most complete way that we could test it because we would have skipped the whole running it through the logging engine part that is really important to us. We can't actually see how it goes through log4pearl unless we actually send it through there. Yeah, it wasn't really easy to figure out what the bloody hell test log4pearl was doing. And what our test roll does is it actually builds up this really ridiculously insane regex. And since test log4pearl only lets you check one regex or one string, it got pretty crazy. It works, but it's not pretty. It was a really dirty, ugly, nasty hack, and we can talk about it over some hard liquor later if you guys really want to know the details. But as far as the tests go, it's really not too bad. In the case of testing our access log, there's an environment variable that we have to set when the test suite runs. And then we use the log expect method. And we tell it the type of access log we want to check and the information that we're looking for. And that's what happens. We have a specialized version of test mechanize to help us with certain things. So we specify what it is we want to log. We actually then invoke the method that'll actually let the character move, and then we look to see the resulting access log that is produced. So once all this has been passed through fluentd and eventually written out to Postgres in this case, how do we get information out? Because we're just writing it to a JSON table or JSON field in Postgres, it's just as simple as doing any sort of JSON-based query in Postgres. And here's just a couple of examples of what those look like. Game balancing and log analysis with regards to game balancing. This is really important, and this is what we're tackling right now. We need more than just simple SQL queries. We're going to actually have to do some measurements and take some statistics on these. So using randomness is one example. For each type of role, we track the chance to succeed the role and whether or not it was successful. And then periodically, eventually we're going to be doing this daily. We're going to determine what the average role was, the percent of successes, standard deviation, and some other things. And we as game developers and the creative team, for game balance purposes, need to determine overall for this period of time, were roles coming out, were they turning out too high, too low, were they what we thought they should be? And what we're implementing is pretty much an easy, medium, hard switch for different pieces of the game. And these are just going to map to multiples of the standard deviation in the game, where where a normal roll would be like 0 standard deviations away from average. If we need to make things easier, we might shift that 1 standard deviation back one way. If we determine that everything's easy and we need to make it a little bit harder, then we're going to want to shift the difficulties of the roll by 1 standard deviation or more the other way. We wouldn't have this information if we weren't logging all of this information. We are still accumulating data to come up with meaningful statistics. Once you all start playing in October, when the game comes out, we'll have more of this information. The other thing about free-to-play games is they're intended to be slow, but not too slow. They don't want to be. You don't want to make them so slow so that people get bored and leave, but you don't want them to grind through it in a couple of weeks. If it's free to play, you need to keep people playing in order to spend money. So we need information that we're collecting this way in order to determine that. We track experience gain, look at the daily progression over time, and much like we did for the randomness, determine what the average gain per day is and what the standard deviation is, and we can use this to determine if we need people to level faster, level slower, and the analysis that we're going to do on this data is going to allow us to do it. Our current fun is balancing the economy. And this is a really complex issue because it involves more than in-game currency, because we need to measure player time, because this is a resource in the economy. We need to measure real money that they're turning into items, skills, and benefits in-game. That's also a resource. And we need to see where the resources are flowing in the game and how they're being used. In economic terms, and I'm oversimplifying this, your economy is just a transfer of one resource, in our case, time, money, or an item, for some other resource, a course, an item, some sort of player skill. So we need to log every type of transfer in the game, and we need to know the absolute number of all resources that we have in the game. If you think back to the exchange class that I showed a little bit earlier, that exchange method that we have allows us to capture all of this. I trade one item for another with another player. That gets routed through our exchange class and it gets logged. If I just flat out buy an item from another player, it gets routed through the exchange class, and both ends of that are. A more complicated example, I spend money on a course at the university. And a week later, I come back and I've completed that course. The actual amount of time it took to complete that is also a resource, and that gets fed through the exchange, and that gets logged. And then what this is allowing is it allows us to capture both the state and the flow of all the resources in the game. And once we have all this, we can start doing some interesting things like that. The one tool that we've identified that is really going to help us is what's called a Sankey diagram. There's other things that we can use too, but this is the most interesting one to show, and we're in the process of developing this off of the data that we collect so that we can see what resources are going into the game and then where they're ultimately going. And being able to produce this once we have all that data is a lot easier than just being able to write a couple of reports or dumping some data for the narrative team and say, hey, here's your economy, make some sense of it, and we'll make, after you've had a chance to suck on this for a week, we'll make some adjustments for you. So as the amount of data that we collect grows, we're going to need help processing and churning all this data. We've had some experience with Redshift, not me personally, but it's based on Postgres, and there are some ancillary products that work with Postgres that we can also use to manipulate and analyze data in unique and interesting ways to get better information out of the game. Keen.io is another service that provides something similar. And as the amount of data that we collect grows, we're going to need a way to search for specific things, and so we'll probably end up wiring something like Elasticsearch to this as well. As far as log retention, as you can imagine with a massively multiplayer game, we're going to produce a lot of data. And it's really important for game balancing purposes, but where do you keep it all? The current plan, at least through our alpha and beta periods, is to archive data after 1 month. Because this game is so agile and it's constantly being updated, and the game changes so much over the course of a month, anything older than that is really not all that meaningful to us anymore. And eventually we can expect we're going to have to archive this more frequently, weekly or every couple of days. But anything too old becomes less relevant for us. Some other things that we have planned for the future. I mentioned earlier overall verbosity versus individual verbosity. We currently have overall verbosity implemented. As players start cheating and breaking things and being a pain in our ass, we'll eventually have to create some individual logging constructs to monitor everything that a character is doing, so that we can take appropriate action if they're cheating, if they're harassing other players. A/B testing results is something that's really important to us. As I mentioned, we're not game developers, and while we think we have some pretty amazing ideas and some of the best ideas out there, we know we're going to miss the mark, and we are really dependent upon our players to say what worked better, and we need to capture those results and do something with them. And we don't have a whole lot of infrastructure in place yet, but as our infrastructure grows, we do intend to use fluentd to send that information to Postgres, Nigos, and other services for analysis. So some final thoughts for you. Logging as a process, don't expect to get it right. I had originally said don't expect to get it right in the first shot, but honestly, after a little more brainstorming, don't ever expect you're going to get it right. Just hope that you get it good enough. The most important thing that we found, and I think probably what we spent the most time on doing this, is make something that's flexible enough to expand later. You don't ever want to code yourself into a corner with anything, but when you need to measure what it is that your application, your game, whatever is doing, changing out the logging is a real pain, and you want to make it easy for yourself later to fix things, make adjustments, make enhancements as it goes along. We liked our Moose approach because this really allowed us to do that. As we need to add more things, all we have to do is add a new log event. And the other thing to be prepared for is once you show people what you can do with the information, they are going to constantly ask you for more. The little bit of information that we've been able to provide has been invaluable already, and the more you give, the more that they want. So be prepared for that. It's like a fire hose. I'd like to thank Case and Noel, who are both sitting here today, because most of this was on their shoulders to implement, and they did a fabulous job. And then that's where I got the Sankey diagram. So, does anybody have questions? Yes.
So it seems like this would be almost all the same code that you use for like an achievement system, and maybe even for knowing when a quest has been completed, depending on, I don't know exactly what your game is. I haven't played it very much yet, so it's not related. But is the code used for the same things? Or?
That's actually a really good point. We need to track, right now the missions are stored in pretty much a tree data structure, and it gets stored as a JSON field in a table in Postgres. We need to track where a player's at, because they might go through part of a mission and then come back later and decide to play it. This is actually one mechanism that we can use to do that. We do have a leaderboard system right now, and it's pretty hacky the way that it does it, but this is something that we want to use to augment that process for generating the leaderboard, because Right now, the leaderboards are a process that run once a day, and they're really slow and they're really inefficient. So having something that's more easily parsable and able to be analyzed is going to be a great tool for that. So thank you for reminding me of that. But it's really important too for knowing where players are in the mission, and especially because some missions are repeatable and some are not. And so we need to know the next time they go back to that quest giver, it's like, you know, oh, well, you screwed me over and sold me out to the authorities. It's like, I'm not going to help you anymore. Yes?
So this is logging structured data. Is that is arbitrarily structured data, I assume? Just whatever. I mean, I know you're defining it in your roles, but as far as like logforpearl and fluentd are concerned, you're just passing in arbitrary data.
Yes. Yeah. And fluentd is nice because I can flip back a million slides, but the configuration is pretty flexible, and you can just set up a simple set of text-based rules to tell it where you want to go. The reason why we ended up sticking with the JSON data type in the table was because rather than creating all these individual tables that even those might not translate the best for the type of data that we're doing, we can only have to worry about defining one table type, and then we can throw pretty much any arbitrary data into it at that point for later analysis. Any other questions? Thank you very much for
Sorry, I was just following on with that question. We've considered JSON, but that's really good when the data is not well structured or could change later. Mm-hmm. What about the notion of mixing, having some things which you know you're always going to have, and throwing the rest into a JSON log?
That's one of the great things about fluentd is setting up multiple appenders. They have the PG SQL data type too, and you can specify multiple appenders, and then this match rule up here will look at each incoming message. You can tell it which part of the JSON that you're throwing at it to look at, and you can say, I want these messages to go to this JSON table, but then these other types of events that are coming in, just log those to a regular table like I'm used to.
What's the purpose behind logging into random? To make sure the generator's not working?
To make sure that the generator is effective and it's not producing either too many successes or too many failures. But it gives us some flexibility in building out the system, because right now it's when you do something in the game, it's one shot, pass or fail. And our narrative team really wants to change this logic and have it's like, okay, you know, this player is doing this action in game, but you know, we don't want it to be just pass or fail. We don't think that's really representative of how this skill is going to be used. We want them to be able to succeed on, like, if they succeed on 3 of 5 rolls, they will pass this particular skill check. For us, having implemented that, once we implement it, we need to log the results of that to see, was this the right decision to make in terms of game balancing? So it's more than just how the effectiveness of the random number generator is, but the process by which we're producing the random numbers, is that also effective? Any other questions? Thank you very much for attending. I appreciate your time today.